instructions. It's just exactly that. It's going to be all word problems. This is probably the most legit thing you could ever do, which is what people hate the most. Like, when am I going to use it? Look at the word problems. They give you a better idea. So we're going to be constructing some equations based off some of these problems. We'll take our time. We'll make sure you understand where stuff's coming from. And please ask questions. Ask me questions. I'm going to ask you to ask me questions instead of saying, are there questions? Because nobody ever wants to say, it's me. I don't know what I'm doing. So let's get started here. Is this even a problem? No, it's just instructions. And you know, there's nothing here that you don't already know. It's important to be able to take some type of expression, right, Grecolio, and convert it to math so that we can math with it. But here's one. Way back then, there wasn't unlimited texting plans.
Oh my goodness.
And phones actually plugged into the wall. But anyway, some of the first plans, and I remember these plans too, it depended on what you paid a month, and then you had to pay for your texting, because texting was big back then. Yeah. So you could buy packages where they'd give you like 50 texts or something, and then if you wanted more, you'd have to get more.
That's sad.
Yeah, it was small amounts.
I had that.
They were very small amounts. There was no. Thank you. You guys are already going crazy. 50? I do that in a day.
I do that in like 2 minutes.
But anyways, let's assume we're back in the 90s, and I was in high school. I actually graduated from high school. And you had to choose between these two plans, and you're like, hey, you know, which one's going to be the better deal for me? So I know that there's Plan A, and Plan A charges me $15. Never charge $15, but anyways. They charge you $15, and then it was 8 cents for every text. The other plan, though, charges you a monthly fee of $3, which is much less than the $15 fee, right?
Yeah.
But you're going to pay 12 cents for every text message there. Now the question is, obviously, right, which one should I get? Which is going to be the better of the two? Right? So we have to stop and think about, what's one question we want to ask? Go ahead.
Oh, I don't know about a question you want to ask, but I have a question I want to ask.
Go ahead.
The cents per text, is that like past your?
No. Well, even if it was, it'd be fine.
Okay.
But we'll say that there's 0 text messages included in this plan. You pay for all your text messages, and that's what this is. What's up?
Is it per text you send or like the ones you receive?
Well, back then they used to charge you for both.
Oh.
Yeah. Every text you sent. But yeah, well, you know what? Let's pretend right now that it's everything you send. Yeah, it really depended on the plan that you got. It was really. I've gone through. I went through so many carriers, ridiculous. You guys remember Alltel?
Yes, yes.
I had
I do
Alltel.
remember that. Sorry, I'm like really shook 'cause I forgot about that.
I think I've gone through all of them. AirTouch. You guys ever get AirTouch?
No.
AirTouch. AirTouch was big on paging.
I think I had
On
Alltel when I
pagers?
was like.
Anyways, let's get back to the problem. So let's pretend we're in the 90s and we have to decide between these two plans. There's a very important question I got to ask myself, isn't there? What is that question? Anybody tell me? How many text messages am I going to be sending, right? So what I need to do is I need to decide, okay, when will these plans be better after a certain number of texts, and when will it be better if I text less than that amount? So what we're really going to do here, I don't know if you can foresee it, is we need to figure out where these two cross each other. We're going to create a system, find out where they cost the same, and then I can make a decision based off of that. Does that make sense?
Yeah.
So I know that plan A, we're going to say, let's call this function A. So the cost here, with respect to text messages, is going to be $15 automatically, plus 8 cents for every text. Right?
Yes.
Now, the other one, we're going to call this one function B, because it's plan B. So this is going to be B of t, with respect to text messages. Its cost is $3, but it's 12 cents for every text. Now, I want to know when these two costs are the same. Because then I can make a decision, correct? AKA the intersection of the two lines. So what I can do is if I'm saying, hey, I want to know when they're equal, I don't like that. When they're equal, I'm trying to figure out when 15 plus 8 cents per text equals $3 plus 12 cents per text. Make sense?
Yeah.
Cool. And then what we're going to do is we're just going to solve it here. We're going to subtract 3 to both sides. That's gone. It's going to give me what? 12 plus 0.08t is equal to 0.12t. I'm going to subtract 0.08t. Is equal to, what is that? 0.04 cents. So when I divide by 0.04, what do we get? Is it 30? 1, 2, 1, 2. So is it 300 text? So, well, at this point, I mean, we could plug it in, but we don't need to. We already have a very important number here. Text messages, right? If I'm going to send more text messages, because 300 is going to be my limit, right? If I'm going to send more than 300 text messages, which is the better deal? Is it A or is it B?
12 cents.
A. It's going to be the one with the... Because even though I'm paying more up front, I'm paying less per text message. Which means once I hit 3,000, I'm going to be only be paying 8 cents per each one.
And how about you prove it mathematically? Like, would you plug it into the equation?
Yeah, you could do that. Here, let's do that. That's a fantastic idea. Hey, let's do some math.
Yes.
Let's pick something, I don't know, bigger than... Because if I plug in 3,000, what am I going to get for these?
300.
I'm going to get the same thing, aren't I? Is it 300?
Yeah.
Why did I put 3,000? Sorry. If I were to take 300 and plug it into these equations, would I get something different?
No.
No. Because this is where the two lines would intersect, meaning that at that specific point in time, they're exactly the same value. You don't understand?
Why is A the better D?
Alright, well, let's do this here. Oh, that's not what I wanted. No, here. Let's go ahead and graph those real quick. You guys remember the equations? What was it? 15?
Yeah.
I'm going to do this graphically real quick. 15. Why for you know want to work?
0.08.
Why you not like me today? 15 plus 0.8x. And the other one is 3 plus 0.12x.
Yeah.
Alright, cool. So let's go zoom standard, zoom 6. Let's see what happens here. Ah, that's not going to work, is it? No, because our 15 is going to be way above that.
Yep.
Yeah, so let's zoom out. Oh, I've got data in there. Sorry. I got some statistics in there. Statistics. So let me turn that off first real quick. 4. Okay, now also, let me go back to this graph. Because this graph is pretty bleh. I'm trying to find out where the two lines cross each other, right? And these lines represent cost. My window is off. Where should I have my window? Somewhere about. Yeah, so does my X-min have to be negative 40?
No, it's 0.
Does it even have to be 0?
It's like 210.
Let's go with like 200.
Yeah.
And then my max will go 400.
Yeah.
What's our scale going to be at? You want to go by tens? And then let's see here. Minimum should be what, 0? You want to try that?
Yeah.
40's fine.
And then we'll go by tens also?
Sure.
You guys want to go by tens also?
Yeah.
Alright, let's try that. Maybe a little higher on the Y?
Yeah.
Okay. So back to window.
Like.
Well, we have 40, so let's go 60.
Yeah, because 39 is the Y.
Okay. So this is going to be a little bit better. These are our two cost functions, right? Right now, let's see here. What did we say this point was? This is 300 text messages.
Yeah. Yeah.
Right now, the red line is the cheaper of the two, isn't it?
Yeah.
So this is cheaper. That represented the... Oh. JK. It represented plan A. No, red was plan B. And then when we go graphing and we go to the blue line is over here, which is the cheaper. So after 300 text messages, plan A is cheaper than plan B. Now, if I'm going to send less than 300 text messages, then I want to go for plan B. Make sense? Simple enough? Now, this used to be a lot better because, I mean, there was things that were very different back then. Like back then, in the 90s, there was 2 rules. Don't talk to strangers, right? And don't get into strangers' cars, right? Especially don't meet with people on the internet. That was 3.
Oh, yeah.
But now we use the internet to call strangers to get into their car, which is ridiculous. We call it Uber. So it's kind of things have changed. But back then, like, you know, getting a taxi, the taxis charge different things too. You know, they have a different initial fee and different charge per mile. So the question is, which taxi do I want to use if I'm going to go in town or if I need to go down to the airport? So you can do something like that if you wanted to. Figure out which one's going to be cheaper for you. Make sense?
Let's take a lift.
Let's take the lift.
Do you say biggest strip? I mean, is there like a certain limit?
Hey, it's fun down there.
Let's be.
No, taxi will take you as far as you need, as you want.
Walking down, sure.
So, like,
Usually, I'm going to take that back. You have to ask them, because some will, like, I'm not taking you to California.
Why not, bro?
I'm paying you by the mile, right?
Whoa.
Yeah, you do.
Paying by the mile?
Have you not ever been on a taxi service?
Yeah, you pay by the mile.
You pay an initial fee.
Give me the responsibility of everybody in the truck at once.
All right, I'm going to move on. Questions on this problem? Ask me some questions. How did I find out what?
In the back.
Well, we found the intersection, right? We said the intersection was 300. Let's see. Red, I should use the same color. Red is plan B. And blue is plan A. So the lower the line, the cheaper, right? There comes a point when it's $300 or 300 text messages where they're both the same. If you're going to send exactly 300 text messages, who cares? Pick the name that sounds cooler to you or whatever, I don't know. But here's the deal. Since the red line is less or costs less, under 300 text messages, that would be the better deal. But if you plan on sending more than 300 text messages, then you want to go with plan A. Because that line is lower, which means costs are lower. Okay? So,
So if the question asks, like, which plan would be better if you sent,
if they ask you for a specific amount, hey, you know what? Your grandma sends 1,000 text messages. You know, which of these plans you should use? You would go with plan A. Okay? Other questions in the back?
that's crazy.
What's crazy?
That you had to pay for every single plan.
Oh yeah. Back then, it was funny.
How much do you pay by the mile?
Well, it's crazy to
He's still on the
He's still on the
taxi.
taxi thing.
I think it's a few cents, but
Oh,
but they build
I
up.
thought it meant like $3 a mile.
No, initial fees. I don't know if it's like 10, yeah, and then they'll charge you for every mile, and it could be dollars,
What
but
is initial?
more than likely it's cents. I don't know. Go look it up. Casa Grande Cab. Not right now though.
I didn't know that they had taxis.
Cabs are taxis. Greyhounds are different. They'll charge you a flat rate.
All I know is run, hitch a ride, or bike.
I know run. I'm good at running.
Someday when I grow up. All right, we're good here. Anybody want to ask me more questions about this?
So I heard someone earlier over there say I don't know
All right.
how to do this.
Let's try this one. On a certain route, an airline carries this one's going to be interesting. On a certain route, an airline carries 8,000 passengers per month, each of them paying $100. A market survey indicates that for each $1 increase in ticket price, the airline will lose 100 passengers. Let's start by expressing the number of passengers per month and as a function of the ticket price X. Go. Do a pair share, please. Talk to your neighbors. Try to figure this out.
So
On a certain airline, they can carry 8,000 passengers, and they charge them $100 per month. Doing a survey, they say if you increase it by $1, you're going to lose 100 passengers. Please express that. Express the number of passengers per month and as a function of the number of tickets.
Oh, so it'd be 8,000 plus 100x a marketing survey indicates that for each $1 increase in ticket price, the airline will lose 10 passengers. So it would be 100. No, it doesn't.
Please don't lose sight of what your function is talking about.
Express the number of passengers per month.
What should your equation be representing?
The
The
number
number
of
of
passengers
passengers.
per month.
Oh, wait, so that's what it is.
It should, yes, your function should equal the number of passengers per month.
Oh,
So is there two functions?
There can be many functions, right? Right now, what are we supposed to be doing? Expressing a function or express the number as passengers per month. So my equation represents passengers only. Passengers only. ¿Qué pasó, Ernie?
I think I have so many numbers.
Oh wait, no, that's
Wouldn't it be 1x when it's not good? Because you're talking about your marketing survey. Your market survey indicates that for each $1 increase in ticket price, the airline will lose 100. So like for every $1 increase, we would lose 100 passengers. So it'd be 1 minus the 100x.
Greg, you want to try this out, please? Gracious. behind you?
No. I mean, like, I want that point.
Make it no joy. Hey, Joseph.
Pick on a random person, like, the random
I only want the number of passengers. So my function should be the number of passengers with respect to X, right? Now how many passengers do I service every month? 8,000, right? So that should be a given. That makes sense?
Yeah.
Now I will lose passengers, won't I? If I change the price?
Yeah.
That's a minus.
Oh my god, did I get this?
How many will I lose? 100. 100x?
No, X plus 1.
X plus 1?
Minus 1.
No, it means
No, it's plus one because every loss of 100 you add one.
Well, remember, it's going to be cost though, right?
Yeah.
So how do we adjust for that?
One add.
Because how much do we charge them?
100.
100, right? So how can we express that with the original 100 in there already? That way we only throw in a cost.
No.
I hear where you're going. That's pretty close. Say that one more time. The cost,
Subtract 100.
subtract 100.
Why?
Because this way, if I say, hey, you know what, I'm going to charge, let's do it real quick. I'm going to charge, how much, 101? Let's go over 1. 101, that's going to give me 101 minus 100, which means I have a $1 change. Okay, now I know some people saw that by itself,
Okay.
but if all we're doing is creating a function that all we're doing is throwing the cost in, we have to express it this way.
Every dollar you.
So every dollar, we're going to lose, oops, you don't write 100 backwards, 100, so that would drop our 100, right? And if the cost was 102, then that 100 takes away the origin that we already originally
That
charged.
makes sense.
Okay?
Oh, that makes sense.
That make sense?
Yeah.
Yay, hip hip hooray, hip hip hooray, hip hip hooray. Say that one more time? Right, but I want to make sure that I put this minus 100 because that's why I charged you anyway, and you were okay. So if I don't change the price, if I do 100 still, 100 minus 100 is 0, which makes this all go away, which means I still have my original 8,000 customers.
That's Einstein.
Dilly dilly.
Okay, dilly dilly. What's up, life?
Couldn't you just say that X represents the number of units over 100?
Yes. Yes, you can. So let me repeat what Blythe just said. Could I have written, I could have written, can I do this? Yeah, I can. I could have said, delete. I could have written this. But what would I have to have done? I would have to explicitly say X is a number of dollars above the original 100 that you charge. So then you would do the subtraction problem somewhere on the side. That make sense?
Yeah.
Or you could have just left that as one problem here for plug in, spits out, input, output. So that it's not math, input, output type thing. But yeah, there's nothing wrong with that. You just got to make sure that the reader understands this. Okay? Is that what you had?
Yeah.
All right. You guys ready to make this more interesting?
Yeah. Sure.
No.
That was one whole problem.
Hold on. I want to make sure everyone's okay with this one.
Yes.
Questions. Ask me questions. Gregorio. Question. You have a question. Ask it.
I know. I swear.
All right. Oh, don't tell me I skipped a part of it. Tell me this is the part. No. No. What did I? Oh. I owe you a harder problem. Anyways, here's a lot of equations that we already use. Anybody not know some of these? You were okay here?
4/3 pi of r.
Which one?
Any of that, just
The sphere?
Yeah. I had a hard
There's
time
actually a
following.
proof for that, which is really, really cool. I don't know if you guys seen it. Because if you'll notice, these two are very similar.
Yeah.
And what they'll do is they'll take a sphere, or is it no, it's volume, yeah. And they'll stuff it inside of a cylinder, and then fill it with water, and then look at the displacement,
Yeah.
and you'll find that it's 4/3, which is like ah!
Oh, they're using water displacement method to find volume.
Let's see here. What about some of these other formulas? This is just a square cut in half, right? Everyone know that triangle?
Yeah.
And this is just two triangles right here that are added together.
Yep.
Yeah?
Yes.
Yes? No? No? Alright, moving on. Let's try this. Modeling with geometric formulas. A machine produces open boxes. No. You read it for me, Greg. I'm losing you.
A machine produces open boxes using rectangular sheets of metal measuring 15 inches by 8 inches. The machine cuts equal size squares from each corner, then it shapes the metal into an opening box or an open box by turning up the size. Express the volume of the box V in cubic inches as a function of the length of the side of the square cut in each corner and inches.
Okay. Everyone understand the question? So this machine cuts these rectangular sheets, kind of like this, right? And it measures 15 by 8. This is what, 11 by 8 by 12 or something like that?
Yeah.
8.5 by 12, my bad. Regardless, make believe that this is 15 by 8. And then it cuts out the corners, little squares at the corners, right? Well, Maya, sorry, this is no longer yours. So it cuts out little squares, like this right here, and does them on every corner. I think you guys have seen this problem, right?
Yes.
Right? And it does it all four corners, and then what it does is it bends this up, because now you have what would be a little box, right? When I fold all of them up. And they're asking you to express the volume of this box as a function of its length of sides of the square cut from each of the corners. So, drawing a picture always helps. Here's my sheet of paper, yeah? This measures 8, I'll use red, 8 by 15. And we're going to cut out, what's the length of these guys? X. Right? These are all X by X. Okay? Which means that we're going to have, oh, help me here, help me here. 3D drawings, why you not like me? Okay? So the idea is, I need to express the volume of this thing. Okay? Not too bad. What is this length now? Is this no longer 8, is it? What is this length now?
8 minus x.
Eh,
2x squared.
It's 8 minus
2x, 2x.
It's 8 minus 2x.
8, take away the 2 x's. I took x away from here, x away from there. So that is now 8, take away 2 x lengths. Okay?
And then pay attention.
So, because remember, how do we find volume? It's length times width times height, right? So we have, what do you want to call that? A width or a?
That's the width.
That's the width. So we have the width as 8 minus 2x. Do we have a height?
Yes.
Yes.
What is my height?
X.
It's x. It is x. Because that's what we folded up, right? On all edges was x high. Cool. So now, what is our length of our box?
15 minus 2x.
Yeah, 15 take away 2x. So now we can
You
just
just have to solve for x.
just FOIL it out, right? So 15 times 8. What's 15 times 8?
120.
Hold on, I'm trained for this.
120. It is.
It's 120. So 120x. And then what is
Wait, what?
15 times?
That should just be 120.
Negative 30.
Yeah, why is it 120x? It should be just.
Oh.
Oh.
Okay.
Right? Okay. So let's do 15 times 2 is going to be negative 30.
X.
Well, that's negative 30 for the outside. And the inside we've got a negative 16. x as well. Correct?
Yeah.
That's going to give me negative 46x. So negative 46x squared. And then finally I've got 4x cubed
Yeah.
plus 4x cubed. Hey, there you go. There is the formula for the volume of that. I don't want to call it a box.
It's kind of a box, though. Sure.
That shelf.
Shelf.
That thing.
That drawer.
Wait, what do they call in geometry though when it's like that outline?
It's a box with no lid. Oh, you mean the net?
Oh yeah, that.
The net? Is that what you were talking about? Okay. Questions on this problem? Ask me questions. Ask me questions. I tapped out already. You're gonna make people lose their phone privileges.
Why would it be 2x instead of x squared?
I just wanted to say it. See who's guilty. People are like, I'm sorry, my bad. What's up?
Why would it be minus 2x instead of x squared?
Because you're taking. What's this distance here? X, right? So if let's say the whole thing was 8, and I took away an x, right? And then I also want to take this piece away, which is another x. Well, how do you combine those?
2x.
It's minus 2x. Give me a number for x.
12.
12 sounds good. So negative 2, let's say x was 12, okay? And then here's your other one. This would give me negative 24, while this would give me negative 144,
And actually be
or
positive.
positive 144. So you see it's not the same. Okay? Be careful. Okay? How are we on time? You have time for one more?
You have 1 minute.
You had me there for a second. I got more. Alright,
I wish it worked, though.
here we go. Next example. You guys are getting the point here. We need to do some more.
No, some more days.
What?
Have some more.
Let me just process this.
It's cold in here.
What? Let me turn this fan on then. Yeah. Alright. Do we want to do this one? You guys good? I think that we can just do them as we go with the questions so we can answer them tomorrow. But I think you guys get the point. You guys seen enough of these, right? Oh, you don't want to do this one? It's investment.
Let's do it.